Hello, ma'am.
Yeah, hello. We will start at 6:05. Okay.
Hello, ma'am. Am I audible?
Hello.
Good evening, ma'am.
Yeah, good evening.
What
Let's
will
wait
you
for
cover
1 minute.
discussion?
We will start at 6:05. Okay.
Sorry, ma'am.
We will start at 6:05. Okay. Let's wait for a few minutes.
And my question
Okay.
was, what will you discuss in this session?
Week three.
Theory session. It's a theory session, ma'am.
Yeah, theory session.
Thank you. Thank you.
Yeah, good evening, everyone. So this is the open session for week three. Now I'm sharing my screen. Is my screen visible?
Yes, ma'am.
Yes, ma'am.
Okay. So till here you have studied about week one and week two. So you studied about what is statistics, like descriptive statistics and inferential statistics. Okay, and you studied about sample and population. Okay, and then you studied about different types of data, which are categorical data and numerical data. Okay, and then cross-sectional and time series data. And you must have studied about different measurement scales, which are nominal, ordinal, interval, and ratio. Okay. And then in week two, you studied about how to describe our categorical data, right? And in week number three, we will study how we summarize our numerical data, how we what are the different measures for numerical data, and how we represent them graphically. Okay. So basically, two types of variables are there: categorical and numerical, right? So in numerical, there are two types: discrete and continuous. So is everyone clear with discrete and continuous variable?
Yes, ma'am.
Okay. So discrete is basically which takes distinct values on real line, and continuous which takes all the possible values in a certain interval. Okay. So first of all, we will study how we organize discrete data. Okay. So let us suppose you are given a data set in which you have a small number of distinct or different values. Okay. Then how we represent it in a frequency table, we will study that. Okay. So you can see in the example. So here, the data set reports the number of people in a household. Okay, so the following data set responds from 15 individuals. Okay, so these are the 15 values. Okay, in which you can see the distinct values in the data set is 1, 2, 3, 4, and 5. Okay, so what we do for making a frequency distribution table, first of all, we write all the distinct values in the data set. Okay, so in this example, you can see the distinct values are 1, 2, 3, 4, and 5. Okay, then by using the tally marks, we write their frequency. Okay, so everyone knows how we write tally marks.
Yeah, ma'am.
Okay,
Yes, ma'am.
so it is 2. Okay, then 1, 3, 4. Okay, then 5. Okay, then again 2. Okay, then 3 times. Okay, so in this way, you write tally marks for each distinct value. Okay, so okay, so 3 times 3, then 4, 2 times, then 1, then 2, then 3 and 4. Here, 4. Okay, so the frequency for 1 it's 2, then 3, it's 5, it's 4, and it is 1. Okay, so if you calculate the total frequency, it will come up to 15. And you know how to write relative frequency? It is nothing but the frequency for that particular case divided by total frequency, right? So in this way, we write the total frequency, the relative frequency. Is it clear?
Yes,
Yes,
ma'am.
ma'am.
Okay, so this was the case when you have small number of distinct values. Okay, then first of all, we write the distinct values and then we write their frequency, and we can find their relative frequency also. Okay. Now the next is how we organize the continuous data. Okay. Suppose you are given a large number of distinct values, then the previous method, this method can be cumbersome. If you write, suppose you have 65 distinct values in your data set, then this method will not be much suitable. Then what we do, we make classes. Okay, we make class intervals for organizing our data. So what we do, we mix different classes. So there are few terms related to this number of classes. Uh, okay, and okay now yeah, these are the terms. Okay, so what are lower limit and upper limit? Suppose this is your class interval. Suppose you are given a class interval like this, 5 to 10. So 5 will be your lower limit and 10 will be your upper class limit. Then what is class width? Class width is nothing but the difference between the lower limit of the first class and the lower limit of the next higher class. Okay. And what is class mark? Suppose you are given this interval, 5 to 10, then what will be the class mark? It is the average of the two class limits. So here in this case, the class mark will be 5 plus 10 divided by 2. Okay, we will see all these things in example also. Okay, and the point number 5 says that a class interval contains its left end but not its right boundary point. So suppose you are given an interval 5 and 10. Okay, this interval, this class. Okay, so in this class, 5 is included, but 10 is not included, right? Suppose you are given some data points like 5, 8, and 10. Then 5 and 8 will go into this class, but 10 will not belong to this class. Okay. So the upper boundary point is not included in the class interval. Okay. Now let's see your example.
Ma'am.
Yes.
So class, can you please scroll up?
Yes.
Yeah. So class mark is the average of the same of the upper limit and the lower limit, right?
Yeah, of the same class, of that particular
Okay.
class.
Okay, ma'am.
Okay.
Sorry.
Yeah. So now let's see example. So here you are given a marks obtained by 50 students in a particular course. Okay. So these are the 50 marks of different students. So here you can see we are having many distinct values. So what we do, we make classes. So we make classes in such a way that it should include the minimum value starting from this. Like it should, the lower, like for the first class interval should contain the lower limit. I mean the lower minimum value of the entire data set, and the maximum value should belong in this interval. Okay. Okay. So here you can see that we have divided the whole data set into classes, like, and the class width is yeah, 10. So 30 to 40, 40 to 50. Now if you see on the data set, the first value is 68, right? So the 68 will belong in which class? Anyone can tell?
60 to
60
70.
to 70.
Yeah, 60 to 70, right? Then we have another data point 79. So 79 will belong to this class, 70 to 80, right?
Yes, ma'am.
Then 38. So 38 will belong to first class,
Yeah.
right? And in similar way, 68. 68 will belong to this class, 60 to 70, right? So in this way, you will write the tally marks and you will write the frequency. Okay. And similarly, you will find the relative frequency also in the same way as we find it earlier, right? So this is the frequency table for this data. Okay, we write tally marks first and then we count it, we write frequency and then we find relative frequency. Okay, so if you are given a large data set in which so many distinct values are there, then we use this method, right? Is it clear?
Yes, ma'am.
Okay.
Ma'am, I have a little question.
Yes.
Ma'am, when we take like a 70, what about
Sorry.
70? What about 70, ma'am?
Yeah. So about 70. So see what I said that you have a class 60 to 70. Okay, and the next class is 70 to 80. So here you can see that the upper limit is not included in this class. Okay, so 70 will belong to this class. Okay, and 80 will belong to this class 80 to 90. Okay.
Okay, ma'am, clear. Ma'am.
Yes. Now the next thing is how we make the histogram for this data. Okay. So, so the first step is obtain a frequency or relative frequency distribution of the data. Okay. So we have seen how we make frequency distribution for the data. Okay. So first of all, we make this frequency distribution. Then in the next step, draw a horizontal axis on which to place the classes. Okay. And on the vertical axis, which displays the frequency or relative frequency. Okay. So we will see it in the example in the next. Okay. So on the x-axis, we represent our classes. Okay. Like suppose 10, 20, 30, 40 in this way. And on the y-axis, we represent the frequency or relative frequency. Okay. And then the step number 3 is for each class, construct a vertical bar whose height equals to the frequency or relative frequency of the class. Okay. So then we make bar for each class. Suppose this is your 5. Okay. And frequency for class 10 to 20 is 5. Then we make bar like this. Okay. And this bar, the height of the bar represents the frequency of that class. Okay. And the next thing is label the bars with the classes. Okay. And the horizontal axis with the frequency name or variable. And vertical axis with frequency. Okay. So on the x-axis, we represent classes. So we should mention that the classes or whatever in the question given. Okay. And this is your frequency. Okay. Now see it with example. So here, this is your class interval. Okay. On the x-axis, we have represented our classes. Okay, 30 to 40, then 50 to 60, 60 to 70, then 70 to 80, then 80 to 90. Okay. And their frequencies are given here. So for class, first class, 30 to 40, frequency is 3. So we make bar like this. Okay. Then for 40 to 50, the frequency is 6. Okay. So it will be like this. Okay. Then for 50 to 60, it is 18. Then 60 to 70, it is 70. Then 70 to 80, the frequency is 4. Okay. And then 80 to 90, it is the frequency is 2. Okay. So in this way, we make our histogram. Here I have made it with a free hand, so lines are not straight. Okay. But the width of the bar should be equal here. Okay. So in this way, we make our histogram for the continuous data. Is it clear?
Yes, ma'am.
Yes, ma'am, it is clear.
Now the next graph is stem and leaf diagram. Okay. So in stem and leaf diagram, what we do, we divide the number in two parts. Okay. So each observation is divided or separated into two parts. Okay. So let us see example. So we have 75, right? So we divide the 75 in two equal parts, not equal, but two parts. Okay. So the first is called stem, and the other part, this part is called leaf. Okay. So suppose you are given two numbers, 75 and 78. Okay. So the stem is same for both, 7.
Yes, ma'am.
Okay. And the leaf will be 5 comma 8. Okay. Now take another example. Suppose you are given 34, 36, 38, and suppose 45, 47, and 49. Okay. Now you have to make stem and leaf plot for this small data. Okay. I'm writing it here. Suppose this is your stem. Okay. And the leaf. So you can see that for 34, 36, and 38, the stem is 3, right? The stem is
Yes, ma'am.
3. And for the leaf part, 4, 6, and 8. Okay. So it will be 4, 6, and 8. Okay. And we always write the number in increasing order here. Okay. So we should not write it like 6, 8, or 4. Okay. It should be in increasing order always. Okay. And then we have numbers 45, 47, and 49. Okay. So the stem will be 4. Okay. And the leaf part will be 5, 7, and 9. Okay. Is it clear?
Yes, ma'am.
Yes, ma'am.
Okay. So these are the steps that I have explained you. So the step 1 is think of each observation as a stem consisting of all but the rightmost digit and leaf rightmost digit. Step 2, write the stem from the smallest to largest. Okay. So we start by, and here also we write in the increasing order. Okay. We should not write like this, like 4 in the first place and then 3. Okay. We should write it in the increasing order only, right?
Yes, ma'am.
And then write the leaf part. Okay. Here also we have to write in increasing order. Okay. So these are the steps which I explained you by this example. So in this way, we make stem and leaf plot. Okay. So suppose this is your example. Okay. In this, following are the ages to the nearest year of 11 patient admitted in a certain hospital. So this is your data. Okay. You have to draw a stem and leaf plot. Okay. So you can see this is your stem and this is your leaf. Okay. Now you can see that the minimum values, you can arrange the data in ascending order also. First, like 15, sorry, the minimum value is 10. So 10, comma 15, then 22, 23, 25. Okay. In this way you can write. Then you can see what are the stem for the given numbers. So stem is 1, okay, 2 for this, 2 for this number, 3 for this number, again 3, 2 for this, and 4 for 45, 1 for 10, right? So in this way, we check stem. So first of all, we write stem and the corresponding leaf part. Okay, so 10 and 15 are there. So first we will write 0, okay, and then we will write 5. Okay, so the digit, the number at the unit place, we write them in the leaf part. Okay.
Yes.
Okay, it's clear.
Ma'am,
Any doubt
like,
till here?
what if like we have 3-digit numbers like
Yeah, okay. So if you have 3-digit number like 345, 346, 342. Okay, so what we do is So in leaf part, we write the unit place number like 5, 6, and 2. Okay. And the stem will be 34. Sorry. Okay.
Okay.
So in leaf, we generally use unit place only. Okay. So the stem will be your 34, and the leaf will be 2, 5, and 6. Okay.
Okay. And like, what
What
is
if we
the difference?
combine two-digit number and three-digit number? Then it will be very much chaotic to understand, like whether it is a three-digit on the stem side and leaf side.
So the general rule is to represent in the leaf part. Generally, we use the unit place number only. Okay. But if you are using another thing, if you're writing like this, 3 and then 42, 45, this can work, but this is the correct way. Okay. Then you have to mention like this is your stem or this is your leaf part. Okay. Because if you have seen the questions in the activity, whenever something like this or stem plot is given, then the notation is also given. Like here, 105 represents 10 and 15. Okay, then you have to mention this thing. But this can also work, but the general approach is the correct way is this only. Okay.
Okay, ma'am.
And like representing our like numbers in this stem leaf form, like it's just a representation, right? So
Yeah, it is just a representation.
like we cannot do some like arithmetic and all,
Sorry.
like some operation on this, like these kind of data sets.
We can do. Okay, this is just to give you an idea. Like, uh, I mean, you can perform anything on that. This is your data. If you want to find mean, median, mode, something, then you can find. Definitely, you can find. You can perform operations, but this is just this plot is just to represent the data.
Mm.
Okay, suppose you have so many digits, and then if you it is the best way or a good way to represent the data like this. Okay, it will be easy to write. Suppose if you have so many values, okay, like you have 6, 7, 8, 9. Okay, if you write like this, then there will be too many values, but this is a better way to represent the data. Okay, like here you can see that the minimum value start from 1, so it is 10, 15, 16, 17, and then 22, 23, 25, like this. Okay.
Okay.
So next thing is descriptive measures. Okay. So basically two types of measures are there, measures of central tendency and measure of dispersion. Okay. That we can find for numerical data. Okay. So what this central tendency gives you, it is the measure that indicates the most typical value or the center of the data. Okay. So it basically this measures of central tendency tells you about where the typical most typical values or the center of the data holds. Okay, and dispersion gives you the spread of the data. Okay, it tells you about the variability or the spread of the data. We will see it in the later. What are the different measures of central tendency and dispersion? Then it will be more clear to you. Okay. So basically, central tendency gives you the idea of central part of the data, and dispersion tells you about how the data set is spread out. So the first measure of central tendency is mean. Okay. So this is the most commonly used measure of central tendency. And what is the definition of mean? The mean is the sum of the observation divided by the number of observation. Okay. And mean is also called as average. So this is basically your arithmetic mean. Okay. So what we do for finding the sample mean or population mean, we add all the all the values, not distinct. We add all the values. Okay. And then we divide it by the number of observation. Okay. So the notation we use for sample mean, we represent it by x bar, and for population mean, we use mu for mean. Okay. Is it clear?
Yes, ma'am.
Okay. So now let's see some examples. Suppose this is your example in which marks obtained by 10 students in an exam are given. Okay. So you have to find the sample mean. So what you do, you add all the values, okay, and then divide the number of observation. So 10 observations are there, so we divide it by 10. So it will be 590 divided by 10, which is equal to 59. So 59 is the mean for the data. Okay. Okay. So basically,
Yes, ma'am.
this is the measure of central tendency, which is telling you about that most of the values lying around 59. Okay. It gives you an idea about the central part of the data. Okay. Now in the next example, how we find the mean of the group data. Okay, so suppose you are given distinct values which are occurring more than one times. Okay, so what we do, we write the distinct values first. Okay, we write their frequencies. Okay, and what is the formula? Formula is that x bar is summation of fi into xi. Okay, so it is nothing but the summation of fi multiplied by xi divided by the total number of observation. Okay, so you can find n in this way also, which is equal to summation of fi. So summation fi directly indirectly gives you the total number of observations, right? So here you are taking the summation of frequency, which is 15, okay, and 15 observations are given to you. Okay. So we write distinct values first, then we write their frequencies, okay, xi, okay. So 1 multiplied by 2, which is equal to 2, okay. Then 2 multiplied by 3, which is equal to 6, okay. Then 3 multiplied by 5, which is 15. And in the similar way, we will find for each case, okay. And then we take summation over fi into xi, okay. So this is your formula. So summation fi into xi is 44, this value. Then we divide by total number of observation, which is 15, okay. Or you can find it here also, like summation of fi, summation of all the frequency, okay. So summation of fi into xi divided by the total number of observation, it will give you the mean for the group data. Is it clear?
Yes, ma'am.
Okay.
Yes, miss.
Okay. Now, if you're given a class interval data in the class interval form, okay, then how we find it? So in a similar way, we already know that how we make frequency table. Okay. So what we do, we make the classes, or the classes will directly be given to you in the question. Okay. And their frequency. Till here it is clear. We have studied already, right? This part we have seen. Okay.
Yes, ma'am.
The class interval and their frequency. xy was a distinct value in the data set, right? But here, what is xi or mi? It is the midpoint or the class mark for the given interval. Okay. So how we find midpoint? So it is nothing but the 30 plus 40 divided by 2, which is equal to 35. Okay. Is it clear how we find this mi? Okay.
Yes.
So similarly, for 40 to 50 class interval, it will be 40 plus 50 divided by 2, which is equal to 45. Okay. So in this way, we find out the midpoint. Okay. Then we have to find fi into mi. So fi is these frequencies and mi your midpoint of the class interval. Okay. So now you have to find the summation of fi into mi and then divide it by the total number of observation. Okay. Am I audible?
Yes, ma'am.
My screen is visible, right?
Yes, ma'am.
Yes, ma'am, it is. Now, actually, not.
Okay.
Yeah, not your screen
There
is
is
not
a
visible.
network issue. Okay, okay, 1 minute. Just wait for a few minutes. That's visible now.
Yes, ma'am, it is visible.
Yes, ma'am, it is.
Yeah, okay. Yeah, so here we go. So we will find this summation of Fi into Mi, okay, then divided by the total number of observations. Fine. And this will give you the mean for the group data. Okay. So the only difference is that in the previous part, xi's were the distinct values. Okay, but here, what mi or xi is, it is the midpoint of the class interval. Okay, is it clear till this part?
Yes, ma'am, it is clear.
Okay.
Yes, ma'am.
Okay, now we will see that if we add a constant to each data point, then how will it affect to the mean of the data set? Okay, so suppose initially your data set is like this, x1, the different values of the data set, x1, x2, x3 up to xn. Then what you are doing, you are adding a constant to each data point. Okay, suppose c you are adding. So x1 plus c, x2 plus c, x3 plus c. Okay, in this way you are adding c to each data point. Okay, so for this data point, your mean is x bar. Okay, now you want to find mean for this data set. Okay, suppose you are representing x1 plus c as y1. Okay, x2 plus c as y2, x3 plus c as y3. Okay, and this is yn. Now you want to find the data set for you want to find the mean for this data set. Okay, suppose it is y bar. Okay, now I am representing it with y bar. Okay, so here you can see that yi is equal to xi plus c. This part is clear. How this line is written?
Yes, ma'am.
Okay, so yi is nothing but xi plus c. You can see this thing. Okay, so now if you find the y bar or the mean for the second data set, it will be equal to x bar plus c. Okay, so you can check it by the example also. So this is your example. Okay, this is your data set which is given. Okay, now here it is written that suppose the teacher has decided to add 5 marks to each student. Okay, so now what we are doing, we are adding 5 to each data point. Okay, so if you add 68, if you add 5 to 68, it will be 73. Okay, similarly, you are adding 5 to each data point. So now this is your new data set. Okay, after adding a constant 5. Okay, now if you find the data set, if you find the mean for this data set, what will you do? You will add all the values like 73 plus 84 plus 43 plus up to 71 divided by the total number of observations. So total number of observations are 10 observations are there. Okay, so in this way you will
10.
find. So it will be 640 divided by 10, which is equal to 64. Now you can see it is nothing but the mean of the previous data like x bar plus the constant that you have added to each data point. Okay. Is it clear?
Yes, ma'am, it is
You can
clear.
verify it also, this result. Okay, so it's advisable if you remember this result, because it will help you to solve the questions. You don't need to if you know the mean for this data set, okay, then you don't need to again find the data mean for this data set. You can just directly use this formula. Okay,
Mhm.
you just have to add that constant into the mean of this data set. Correct?
Yeah.
Okay, now we will see that if we multiply by a constant, then how the mean will be affected. Okay, so similarly, you can see that this is your initial data set, x1, x2, x3 up to xn. Okay, now you are multiplying by c, which is a constant here. Okay, now this is your y1, this is your y2, this is y3. Okay, now you want to find, so yi is equal to xi multiplied by c. Okay, now the y bar, okay, so mean of this data set, it will be equal to x bar into c. So you just have to multiply that constant into the mean of this data set. Correct? So you can verify it by the example. So this is your initial data set. Now you are multiplying by 0.4 to each data point. Okay, so this will be your new data set. After multiplying by 0.4, now you will find the mean in the same way, summation of all the observation divided by the total number of observation. Okay, so the mean will be 23.6 here, which is nothing but 59, which is x bar, multiplied by c, which is 0.4 here. Okay, so this is also a direct result that you can remember. Okay, so you should remember this line. This will help you to solve the question. So is it clear?
Yeah,
Yes,
ma'am.
ma'am.
Okay, now the next we will study median. Okay, so median is nothing but the middle observation of the entire data set. Okay, so essentially median of the data set is the number that divides the whole data set into two parts. Okay, so suppose this is your data set. Okay, so this will be your median value. Okay, so below this median point, suppose this is your m, which is median. So below this median, 50% values will be there, and above it also 50% values will be there. Okay, so it divides the whole data set into two equal parts. Okay, so the median of the data set is the middle value when the data is ordered list. Okay, and you arrange the data set either in the ascending order or in the descending order. Okay, now here are the steps to find the median. Okay, so what we do, suppose we are given a data set, suppose x1, x2, x3, and xn. Okay, so first of all, we will see the total number of observation. Okay, which is n. So n is the total number of observation. Okay, first of all, we will find the total number of observation in the data set. Now we will see whether it is an odd number or an even number. Okay, suppose n is your 10 or n is your suppose 30. So it is an even number, right? And it is an odd number, correct? So first of all, you find the total number of observation, then you arrange the data in increasing order, or you can arrange in descending order also. Okay. Now, if the number of observation is odd, then we use this formula. Okay. So the observation at this point, n plus 1 by 2, okay, it will be the median for the given data set. And if the number of observations are even, okay, then we have to use this formula, which is nothing but the mean of this data point and this data point. Okay, so the observation n at n by 2th position plus the data point at n by 2 plus 1th position divided by 2. Okay, so the observation at this position will be your median. Now let's see it by example. So this is your data set. Okay, now first of all, we arrange the data set in increasing order. Okay, now here you can see that the value of n, which is the total number of observation, is 7, which is an odd number, correct? Now the median will be n plus 1 divided by 2th observation. Always remember that it is giving you the position for the observation. Okay, not that observation. It's not 4. Okay, it is the 4th observation. Okay. Okay, so basically n plus 1 divided by 2th observation is your median, not n by 2 plus 1 by, not n plus 1 by 2 is the median. Okay, is it clear?
Yes, ma'am.
Yes, ma'am.
Okay, so the 4th observation is 6 here. So 6 will be your median in this case. Okay, now this is your second data set. We have arranged the data set in increasing order first. Okay, so again n is 7. Now n plus 1 divided by 2, so n is your 7. So 7 plus 8 divided by 2. Okay, so 4th observation will be your median. So 4th observation is again 6 here. Okay, so 6 will be the median. Now in the third data set, you can see that we have arranged the data set in ascending order. Okay, so here total number of observation is 6, which is an even number. So what we have to do, we have to find the average of these two observations, which is at n by 2th position and n divided by 2 plus 1th observation. Okay, so n by 2, which means 6 by 2th observation plus 6 by 2 plus 1th observation divided by 2. Okay, so third observation, okay, plus 4th observation divided by 2. So third observation is nothing but 5. Okay, and the 4th observation is 6. Okay, so 5 plus 6 divided by 2. Okay, which is equal to 5.5. So 5.5 will be your median in this case. So it's clear. Any doubt in this part?
No, ma'am.
No, ma'am.
Okay.
That's clear.
Now here is a observation that you can see in the in the previous examples. Okay, so this is your data set number 1 and this is your data set number 2. So you can see that all the values are same except this value in these two data sets. Okay, all the remaining values 2, 5, 7, 6, 7, 3 in this data set also, and here also 2, 5, 7, 6, 7, 3. Only this data point is changed. Okay, now we have calculated the sample mean and sample median for both the data sets. Okay, so you can see that median is same for both the cases, but the mean has changed a lot, right? Is
Yes,
it
ma'am.
correct? Okay,
Yeah.
so what we observe here, we can see that the mean is sensitive to the outliers, but the sample median is not sensitive to the outliers. Okay, so you can see here the 117 is an outlier in this data set. You can see other values are 2, 5, 7, 6, 7, 3, and 117 is very extreme value here.
Yeah.
Okay, so when you add an outlier to the data set, then mean changes. Mean gets affected by this. Okay, because what we are doing in mean, we are taking the sum of all the values, right? Okay. Okay. So suppose if the value of x3 is increasing very much, then definitely this whole value will be changed, right?
Yeah.
And in median, what we do, we median is based on the position of the data, position of the data point. Okay. So
Mhm.
suppose here also 1, 2, 3, 4, 5, 6, 7, 7 observations are there.
Mhm.
Okay. So if you arrange it in the increasing order, it will be like this: 2, 3, 5, 7, 7, and 117. Right? Is it correct? Check it. Uh, 6 is remaining there. 6. Yeah, 6. Okay. So you have arranged the data set in this. Okay. And you can similarly arrange the first one also: 2, 3, 5, 6, 7, 7, and 12. Okay. Now the median is basically the 4th observation. This observation. Okay. It is not. It does not depend on this, like whether the value of this observation. Okay. So whatever the value at this position, that will be your median. Okay, so that's why the median is not affected by the outliers. Okay.
Mhm.
When we say, ma'am, when we say sensitive, are we saying that it will not change, or are we saying that the change will not be significant?
Sensitive means it will be changed.
So when we say median is not sensitive to outliers, that means it will not change.
Yeah. Basically, it is not getting affected by the outlier value. Okay, suppose let's take a, small example, which is suppose 2, 5, and 7, or 2, 5, and 100. Okay, then what will be the median for this data set and for this? It will be 5,
5.
right? So for both the data set, the median will be 5. Okay, it does not depend that whether what is the value of this data point and what is the value of this data point. It is just the second observation. Okay, you have total 3 observations here. So the second observation will be your median. Okay, no matter whatever the value of the other data points.
Okay, so
that's
there
why,
will. Yes, ma'am, continue.
yeah, so that's why median is not sensitive to the outliers.
Okay, so there was this question which said that if that there was a data which was given, and there was an outlier which was present, which we calculate by the IQR. So the question said that if we remove the outlier, what will happen to the median?
So suppose if you are removing the outliers, okay. So suppose in this case you have removed this part,
Yes, ma'am.
okay. Then the number of observation will definitely be changed, right?
It had decreased.
Okay. So the median will be this part. Okay. So this observation will be your median then. So if you are removing the outliers, then the median will be changed. If you are considering them, then it will not affect the median. Okay.
It will not be 5, right? It will be the average of 5 and 6, right?
Yeah,
Uh,
sorry.
6 observations.
Yeah, sorry. Yeah.
Okay.
Yeah,
Okay,
yeah,
ma'am.
we
Understood.
will use that formula.
Excuse me, ma'am.
Yes.
Suppose the outlier that we are taking, it results into the changing of the order in which we arrange the data. So that means now the median will also change if we chose the outlier in such a way that the whole arrangement of the data changes. So I mean, like the fourth observation becomes the fifth one, and the fifth becomes the sixth. So in this way, then the median will also change.
So what are basically the outliers? There is a formula also to find out the outliers. But if you are talking in general terms, so outliers are basically the extreme values. Okay, like in this data set, you are having values like 2, 3, 4, 7, 10. Okay, and your outlier will be like 210. So you can see that this is extreme value. Okay, all these value you can see generally are similar, but this is extreme value. Okay, and suppose minus 100, so this will also be a extreme value here. Okay, or you can say that your values are like this: 210, 215, 200 and suppose
Ma'am,
16,
so
or
here
whatever.
if we
So
take like,
zero. Okay,
yes,
okay, and 1000. Okay, now you can see that 0 and 1000 will be your outlier. Okay, so outlier are the values which are very low from the data set or very high. Okay, so that will not come in between the data points. Okay, so if you arrange the data set, so extreme values it will be either on the left side or in the right side. Okay, so these here you can see the arrangement will not be changed.
ma'am, taking the example that you were explaining, ma'am, here if the data which was available with us was 2, 3, 4, 7, 10, and 210, maybe, then I remove this 210 and I take minus 100 as an outlier. So then the arrangement will be changed as minus, we'll arrange the data as minus 100, then 2, 3, 4, 7, and 10. So in this case, the median
Yeah,
will
so
also,
in
I think.
so in this case, because you are removing this part, right? So that's why it is changing.
Okay, so So that means, ma'am, if if you're generalizing this, that median is not sensitive to outliers, then I
Yeah.
think it is not right, because here it is changing.
See, in this part, you are removing the outlier, but generally we don't have to remove the outliers in the data set. Okay. We are calculating the median for the entire data set as it is given. Okay. Suppose in this data set, if you remove the 117, then the median will be changed. But you don't need to remove the median. Sorry, remove the outlier. Okay.
Okay.
So if you are removing this outlier, then only it will be changing. Otherwise, not.
Okay, that means this is correct to say that median is not sensitive to outliers. But if we
Yes.
remove an outlier and then we introduce some other
See,
number.
then okay, yeah. So in that case, the data set will be changing, right? Because then one
Right.
data point is removed. Okay.
Yes,
So
ma'am.
median is not sensitive. This is correct. Okay. Because what you are doing, you are changing your data set.
Okay.
So these are
Yes.
the other things. Okay. When we remove the outliers, but generally we don't need to remove the outliers. So if you are calculating the median by considering them, then median will not be affected.
Okay,
Ma'am,
ma'am.
I want to say something.
Yes.
If so there is an extreme so for higher value or extreme negative value, then according to the ascending or descending order, we arrange it in that way. Like if it is a very high value like 117, then we put it in the last of the order, so it will never be the median of the data, and it will never affect that median. So that's why median is not sensitive to the outliers.
Yeah, because median is based on the position of the data points and not the value. Okay. Is it clear now?
Yes, ma'am.
Yes, ma'am.
Okay. So yeah. So always you have suppose you have 15 data points uh, in the data set. Okay. Then always the eighth observation, right, will be your median.
Yes, ma'am.
Okay. So no matter what the values the data point holds, always the eighth observation will be your median. Okay. So it depends on the position of the data points and not the value that the data points are holding. That's why it's not affected by the outliers. Okay. And in
Okay,
median,
that
what
means,
we do?
sorry to
Okay.
interrupt, ma'am. That means the
Yes.
observation, that means the median value can change, but that position is going to remain the same. That's what we mean by this.
Yeah. Okay.
Okay.
Yes. Okay.
Yes.
Suppose n is 15, then median will always be this data point only. Right. You can see. Okay. It does not depend the eighth value is very high or low, because that's why we always arrange the data set. Okay. We are arranging them also in ascending order or descending order. Right. That's why the sorting of the data set is also very important here. Right.
Yes.
Yes, ma'am. Because number of observations remain the same, right? Unless and
Yes.
until we are removing an observation. Okay, got it. Yes, ma'am. Thank you.
Yeah. That's why the sorting is very important. If you
Hmm.
if you're finding directly from this data set, then definitely median will not be 6. Okay. Because you
Yes.
have not arranged the data set. So that's why you have to arrange the data set first, and then you can find out that particular observation at that particular position. Okay.
Yes, ma'am.
Okay. Now we will see similarly, as in we see in the mean case, that if we add a constant or multiply a constant to each data point, then how the mean was affected. Similarly, we will see how the median is affected. Okay. So similarly, you can see that the new median will be the old median plus C. So you can check it. You can verify it by the example. So this is your data set given. Okay. First of all, you will arrange the data set, right? Then you will count the number of observations. Okay. So, so in this case, the formula we are using is using is n by 2 plus n by 2 plus 1 divided by 2. Okay, the mean of this n by 2th observation and n by 2 plus 1th observation. Okay, so the median will be 63.5 for this data set. Now what you are doing, we are adding 5 to each data point. Okay, so we have added each data point, 5 for each data point, and then we have arranged them also. Okay, so basically in this data set, which are already arranged, we have added 5. Okay, and then we have calculated the mean. So then you can see that it is 68.5, which is nothing but the old median. Okay, plus that constant. And this thing is always true. Okay, it is a general thing, not for this example only. It is always true. Okay. And similarly, if we are multiplying a constant, then the new median will be the old median times, C, that constant times the old median. Okay. So you can see in general view also like x1, x2, x3, x4, x5, x6, and x7. So this is your data set. Now what you are doing, you are multiplying by a constant to each data point. So cx1, cx2, cx3, okay, cx4, cx5, okay, then cx6, and then cx7. Then what is the median for this data set? First data set. It is x4, correct?
Yes, ma'am.
Okay, and what is median for second data set? It will be c times x4. Okay, so the observation at fourth position will be your median always. If you are having 7 total observations, okay. So the median will also get multiplied by that constant. Okay. So you can verify by this example similarly. Okay. So this is your initial data set. Now you have multiplied by 0.4 to each data point. Then again they have calculated median for the new data set. Okay. So it will be old median multiplied by that constant. Okay. So is it clear?
Yes, ma'am.
Yeah. So the next thing is mode. So it is also a measure of central tendency. So mode is that data point which has the which has the highest frequency. Okay. The mode of a data set is its most frequently occurring value. Okay, or the data point which has the maximum frequency. So you can see it here. So the steps are given like if no value occurs more than once, suppose every value is occurring only one time. Okay, so there will be no mode. Okay, otherwise the data point which have the maximum frequency, that will be your mode. Okay, and mode can be 1 or 2 or 3 or greater than. I mean, it's not always that one value is mode. There can be 2 values that are mode. Okay, it is also possible. So let's see example. So in this case, you can see that 7 is occurring 2 times and all the other values are occurring only one time. So 7 will be the mode for this data set. Okay. And here also you can see that 7 is occurring 2 times. So 7 will be your mode. Okay. And in the next example, you can see that each value occurring only one time. So there will be no mode. It's fine.
There's
Any
an
doubt?
outlier in second and third.
It's clear, right?
Yes, ma'am.
Okay. So now we will see the effect of adding a constant and multiplying a constant. So it is similar to mean and median. Okay, so new mode will be old mode plus C. Okay. So you can see by example also that here 68 is occurring 2 times. So 68 is the mode. Okay, now what we have done, we have added 5 to each part, each data point. So this is your new data set. Okay, we have arranged them also. So here 73 is occurring 2 times. So 73 is nothing but 68 plus 5. Okay, it's clear.
Yes, ma'am.
Yes.
Okay. So similarly, if you are multiplying a constant, then the new mode will be that constant times old mode. Okay. So you can verify it by the example. So here 68 is the mode. Now you have multiplied by 0.4. So this is your new data set. Okay. So mode is 27.2. This and this. Okay. So it is nothing but 68 multiplied by 4. 0.4. It's clear?
Yes.
Can you please mute your mic?
Why do we need to measure
Okay.
of dispersion? 24F206 sulfates.
Can you please mute your mic?
Then you can
Very
also
sorry.
use it.
So till this part, we have studied about the measure of central tendencies. Okay. Now we will study about the measure of dispersion. Okay. So first of all, we will see why we need measure of dispersion. So measure of central tendency, we're giving you an idea about the central part of the data set. Okay. Now we will see why measure of dispersions are important. Okay. So here we are given two data sets. Okay. So in data set number 1, the data values are 3, 3, 3, and 3. Okay. And this is your second data set, 1, 2, 3, 4, and 5. So what we have done, we have calculated the central tendencies for both the data set. Okay. So mean for both the data set will be 3. You can calculate it also. Okay. And the median will also be 3. Right. And mode for the first data is 3. And second data set, there is no mode because every data point is occurring only one time. Okay. So you can see that the measure of central tendency are both for both the data set. Okay, so value of mean and median are same for both the data sets. But you can see that the data set are not same. They are different, right? So now you will see that how measure of dispersion gives you an idea about the spread of the data set. Okay. So uh, in these two data set, you can see that most of the values are lying around 3. Okay, but the data set are different. So how we will know? We will use the measure of dispersion to know this part. Okay, so there are different measure of dispersion. Okay, so what is written here? To describe the difference quantitatively, we use the descriptive measures that indicates about the amount of variation or spread in the data set. Okay, and measure of dispersion, dispersion also, yes.
Can you explain a previous slide?
So see, there are two data sets given. Okay, for both the data set, we have calculated mean, median, and mode.
Okay.
Right? So you can see mean is same for both the data set, and median is also same for both the data set.
Yes, ma'am.
Okay, and here mode is 3, but for the second data set, mode is not available. I mean, there is no mode. Or if you add one mode 3, then mode will also be 3. If you add a data point 3 also,
Yes, ma'am.
then mode will also become 3. Okay, then you can see that all the measure of central tendency are same for both the data set.
Yes.
Okay,
Ma'am.
but you can see that data set are different.
Yes, ma'am.
Okay, so that's why now we will study about the measure of dispersion that will help you to understand how the data set are differing from each other.
Okay, ma'am.
Okay, so measure of dispersion, also called as measure of variation or measure of spread. Okay, so basically it tells you about how the data set is spread out. So the different measures of dispersion are range, variance, standard deviation, and interquartile range. Okay. So first of all, range. So range is nothing but the maximum minus minimum value. Okay, it is the difference of maximum and minimum value in the data set. Okay, so this is your first data set, and this is your second data set. Okay, now you can see that maximum value is 3 here, minimum value is 3 here, and for the second data set, maximum is 5 and minimum is 1. Now the range is maximum minus minimum. Okay, so the range for the first data set 1 will be 0, and for second it is 4. It's fine. Now we'll see how the range is the outliers. Okay, so here is your data set number 1, and this is your second data set. You can see all the values are same except the last value. Okay, so here it is 5 and here it is 15. 5 here and minimum is 1, maximum is 15 here and minimum is 1. Okay, so range is changing because we have introduced an outlier to the data set. Okay, so you can see that if you introduce an outlier to the data set, the range will be affected. Okay, so it is written that though the two data sets differ only in one point, we can see that this contributes to the value of range significantly. Okay, so this happens because the range takes into account or takes into the consideration only the minimum and maximum values of the data set. Okay.
Ma'am.
Yes. It's clear?
Yes, ma'am.
Yes, ma'am.
Yes.
Okay.
Ma'am, what does range represent in general?
So basically, it is giving you an idea. Suppose, like you can see that basically it's giving you the spread only. So suppose the minimum value is 2 and the maximum is 20. So this difference is 10. So it's nothing but just giving you the idea about the differences the minimum and maximum value holds.
Okay.
Okay. So that because it is not giving the enough information about the spread of the data set, that's why we have another measures also. Okay.
Okay, ma'am.
Because from this only you cannot determine the spread from this only. So we have another measures like variance and standard deviation. Okay. So here variance. Okay. So in contrast to range, because range only takes into account the maximum and minimum observation, but variance takes into account all the observations. Okay, that's why it is better than the range. Okay. So what we do in variance, we consider the deviations of the data value from the central value. Okay, so we will see it in the example. Okay, so these are the formula for the population variance and sample variance. So what we do is, suppose we have a number of observation. Okay, so we can make a table like this. So x1, x2, x3 up to xn. Okay, so first of all we will calculate mean for this data set. Okay, so first of all we will find the deviations. Okay, so these are your data points, right? Now you have to find the deviation of these data points from the mean value. So x1 minus 1, okay, then x1 minus mu, then x2 minus mu, then x3 minus mu, up to xn minus mu, okay. Then what we do, we square them. So we find the squared deviation, okay. Now what we do, we have to add all these values and we divide the number of observation. So in population variance, we divide it by capital N, which is the total number of observation in the population, but in sample, we divide it by small n minus 1. Okay. So small n means the number of observation in the sample minus 1. Okay. So basically, we are finding out the deviations from of each data point from the mean value, and then we are squaring them, which is your numerator part. Okay. So in population, if you are finding population variance, then you will use population mean, and if you are finding out sample variance, then you have to find sample mean. Okay.
Ma'am,
Yes.
mu, we are consider mu as like a mean.
Yeah. Mean. So these both are means. This is just a representation that population mean is represented by mu and sample mean is represented by x bar. So these both are mean for the data set. Okay. It's clear. Okay. Let's see an example. So this is your data set. Okay. So we have already computed its mean, which is 59 here. Okay. Now we will see here the table. So first of all, we have written all the data points. Okay. This is your data points. These are just serial number. Okay. So first of all, we have calculated the deviations. Okay. So this is nothing but 68 minus 59. Okay. This is 79 minus 59 because 59 is your x bar. Okay. So first of all, we have calculated the deviations. Then we have squared them. Okay. Now we have to add these values. Okay. Which is your numerator part. So 1898 is the summation of the squared deviation. Okay. Now, if you have to find population variance, then we multiply it by the total number of observation. And if you find sample variance, then we divide by the number of observation minus 1. Okay. Now, in the similar way, we will see that if we add a constant or multiply a constant, then how the variance is affected. Okay. So you can see that if you add a constant to each data point, then the variance remains same. Okay, variance is unchanged. So you can verify it by the example. So this is your first data set. Okay, and we have calculated the sample variance, and it is 210.88. Right. Now we have added 5 to each data point. So this is your new data set. Okay, and in the same way as you calculated variance for this data set, you have to calculate variance for this data set also. Okay, and you will see that there will be no change in the variance. Okay.
Excuse me, ma'am. Ma'am,
Yes.
sorry, but actually I'm unable to understand like what is the use of finding out population variance and then sample variance separately, or means why are we doing this? The value that we are getting is
No, see, in this example, it is just to show you that how we find it. But suppose if you are given the sample, it will be mentioned in the question that this is the sample and not the entire population. Then in that case, if you are given only a sample, which is a small part of the whole population, then you will use sample variance. Okay, it will be mentioned in the question also. And if you are given the entire population, then you don't need to calculate sample variance. You will use population variance there. Okay. In this question, just to show you that how we calculate it. So we have calculated both for this data set. Okay.
so, ma'am, what is this variance indicating? Like, what is it telling us?
So basically, it is giving you that uh, uh, ultimately the spread. Okay. So see, we will see the standard deviation first, then you will be understanding it. Okay.
Yes, ma'am.
Okay. So it's clear till this part.
Yes, ma'am.
Okay. So now in the similar way, you can see that if you multiply a constant, then your new variance will become c square times old variance. Okay. These are the few tip points that you should remember, which will help you to solve the question in less time. Okay. So similarly, you can check this thing also. Now the next measure of dispersion is a standard deviation. Okay, so standard deviation is nothing but the square root of variance. Okay, so if you have to find sample standard deviation, then you will take square root of sample variance. And if you have to find if you have to find population standard deviation, then you will take square root of population variance. Okay. Else the procedure is same for both. Okay. Now you can see that units of the standard deviation. Okay. So suppose in the data set, in this data, in this example, suppose the unit work in kg. Okay. Then you can see that if you are, this will also be in kg. Okay. So these 68 kg, 79 kg, and 38 kg. So all these data points have the unit kilogram. Okay. And if you're subtracting a constant or a value from it, then this thing will also be in kilogram, right? It's clear?
Yes.
Okay. Now in the second step, what you're doing, you are taking square root, square. So now it will become kilogram square. Fine.
Yes, ma'am.
Okay. So it is 9 kg. You are squaring it 9 kg square. So it will be 81 kilogram square. Now you are taking sum of it. Okay. This thing. Okay. In the numerator part, you are taking the sum of squared deviations. Okay. So it will give you the kilogram square. It will be kilogram square, and you're dividing by a constant. Then still it will be in the kilogram square only. Right? So you
Yes.
can see that in variance, the unit gets squared of the original units. But in the standard deviation, what we are doing, standard deviation is nothing but the square root of variance. Okay, so standard deviation is square root of variance. Okay, then again, you are taking square root of kilogram, then it will again be kilogram, right? So standard deviation gives you the same unit as in the data set, but in variance, this units gets squared. Okay. So variance basically, or sample standard deviation basically gives you the spread. Suppose this is your mean, okay, and suppose this is your standard deviation. So basically it gives you an idea that the data set, the data point will be like this, okay, in this interval. So like if your mean is 60, okay, and your variance is suppose 10, then you can say that that the most of the data points will lie in this region, 6 plus 10 and 60 plus 10 and 60 minus 10. Okay. So it gives you an idea of this thing. So how the data points are spread in the entire. Okay, now it's clear.
Yes, ma'am.
Okay. So I have explained you this thing, that in sample variance unit gets squared, but but the standard deviation gives you the same unit. Okay. Now again we will see how it is affected if we add a constant and multiply a constant. So you know that variance is not changed if you add a constant. Okay. So variance is same as old variance. Now in the standard deviation, you are just taking the square root of it. Okay. So this will also not change, right? So standard deviation will also not change if you add a constant to each data point. Okay, and you can verify it. It's clear?
Yes, ma'am, it's clear.
Okay. So, and if you are multiplying a constant, so variance was c square times the old variance. Now you are taking the square root of it. Okay, so it will be, so your new standard deviation will be equal to c times old standard deviation. Okay. Okay, c times old standard deviation, right? Now the next thing is percentile. So what are the percentile? So suppose this is your entire data set. So percentile are the 99 points which divides the whole data set into 100 equal parts. Okay. So also you can see that suppose it is your 40th percentile. Okay. So you can say that below this 40th percentile, 40% data will be there, and above this point, 60% data will be there. Okay. Because it is dividing whole data set into equal parts. These percentile points divide whole data set. All these points, these parts are equal. Okay. So suppose this is your first percentile, this is your second. Similarly, this will be your 99 percentile. Okay. So you can see that median will be your 50th percentile. Okay. So what median does? Median divides the whole data set into two equal parts, right? Okay. So below it, 50% data points will be there, and above it, 50% data points will be there. So we can say that it will be your 50th percentile, correct?
Yes, ma'am.
Okay. Now, how we compute the percentile? Okay. So whenever you have to compute the percentile, you sort the data in ascending order. Okay. First of all, you have to arrange it, and in median case, if you have to find median, then you can arrange the data either in the ascending order or in the descending order also. But if you have to calculate percentile, then you can arrange the data in ascending order only. Okay. You don't have to arrange the data in descending order, because in that case, the values will be changing, right? So
Yes,
suppose
sir.
this is your data set in which you have 100 values, say 1, 2, 3, 4, up to 100. Okay. So your say second percentile is 2, suppose. Okay. Now if you so this is in the ascending order, but if you write it in the descending order, then it will be like this. Okay. Then in that case, it will be 99, but it is wrong, you can say. Okay. So in percentile, we arrange the data in ascending order. So first of all, we find out the number of observation, okay, which is n, and accordingly, we use the formula. Okay. So to find the sample 100th percentile of a data set of size n, so arrange the data in increasing order. Okay. Then we find out the value of np. Okay. So p is nothing but gives you the percentile value. Okay. So if it is 40th percentile, then the value of p will be 0.4. Okay. If it is 60th percentile, then value of p will be 0.6. Okay. That's why we write it like 100th percentile. Okay. So p is lie between 0 to 1. Okay. So now we will find out the value of np. Okay. So suppose n is your 10. Okay. And p is your 0.4. Okay. So first of all, you will find out the value of p. Okay. So it will be 4. Okay. So here you can see that np is an integer. And suppose value of np could be in decimal also, like 4.5 also. Okay. In some case. So you have to see whether the value of np is an integer or not integer. Okay. So if it is not integer, so which is example 4.5, then what we have to do? We have to determine the smallest integer, which is just greater than the value of np. Okay. So suppose the value of np is 4.5, then the smallest integer, which is greater than 4.5, what it will be?
5.
5,
5.
right? Okay, it will be 5. So you just need to find out the smallest integer, which is just greater than this value. Okay. Okay, so the data point at that position will be your 100th percentile. Okay. And if the data, if the NP is integer, which is this, okay, if NP is integer, then what we do? Then NP plus 1 divided by 2. Okay. Basically, we are taking the average of these two values. Okay. So NP is your 4. So 4 and 5. So value at this position and taking the average of it. That will be your 100th percentile. Okay, as we did in the median case also, you can relate it with that. So let's see an example of it. So here you have 10 data points. Okay, value of n is 10. Okay, and these are the different values of p. Okay, so this is nothing but 0.1 indicates that 10th percentile. Okay, 0.25 means 25th percentile. This is 50th percentile. This is 75th percentile, and this is 100th percentile. Okay, so first of all, we find out the value of NP. Okay, n is 10 here. So values of NP will be like this. Okay, so you can see that 1 is an integer. Okay, so we will find the value at first position plus second position divided by 2. So we have to take average of first and second value. Okay, so first and second value are 35 and 38. So we are taking the average of it, which will be equal to 36.5. Okay, now in the next, yes.
Ma'am, why are we doing for the integer like first and second term divided by 2? Only for integers.
So see, so there are 10 data points. Can you tell me what is the 2.5th data point?
No.
Okay, so in that case, we use integer part, which means 3. But if it is 1, then we take average of it.
Okay.
This is the rule. So we cannot directly say that it is, I mean, this is the rule, so we have to use this formula only. Like if you check it also, then it is the 10th percentile, okay, which means that below it, 10% data should be there, okay, and it is giving you the first value. So if you take 1 directly, then it will be 35. Okay, then you can see that no value is below this 35, no data point is there. Okay,
Yeah.
then you can check that it will be wrong in that case. Okay, 10% value should be there below it, but if you take 1 directly, then there will be no value. Okay, so that's why we have to take first value and the next value and the average of both. Okay, so if it is 2.5, then you have to take third value. Okay, which is 47 here. Right, in a similar way you can find for the other part also. Okay, so you can see that it is your 100th percentile. So 100th percentile indicates that 100% data should be below it, right? So this is your you have calculated the 100th percentile, which is 79. You can see that 79 is the last value in the data set. Okay, so all the values of the data set lie below it. Okay, now it is verified. Yes.
Yes, I got it.
Okay.
Yes.
Okay. Okay. So now we will study about quartiles. Okay. So yes.
In the previous slide, 10 is considered 79. Why?
See, there is no value next it 79. Okay, there is no value after it, so we can take it as 0 also. Sorry, no, not the average. Since there is no value, right? You can just try to understand it, what this percentile value is trying to say. So you can say that 100 percentile means that all the values should be below it. Okay, so definitely it will be the last value.
Yes, ma'am.
All right. Now the next thing is quartile. Okay, so quartile is nothing but the 3 points which divides the whole data set into 3 equal parts. Okay, in percentile, it divides the whole data set into 100 parts, right? But quartile divides the whole data set into 4 equal parts. These 4 parts will be equal. Okay, all are containing 25% of the data. Okay. So this is your first quartile, this is your second quartile, and this is your third quartile. Now again, you can see that your second quartile will be your median. Yes, because 50% of the data below it. Okay, and 50% of the data above it. Okay, so it is your median or 50th percentile, you can say, right?
Yes, ma'am.
Okay, and now first quartile. So first quartile, below first quartile, 25% data will be there. So 25 is what? 1/4 part of total. Okay. Okay. And below second quartile, 2/4, which is 1/2. Okay. So half of the part, half of the data points will be there below the second median, second quartile, which is median, right? And below the third quartile, okay, 75% data will be there, right? Which is 3/4.
Yes.
Yes,
Okay.
ma'am.
Okay, so these are the 3 points which divides the whole data set into 4 equal parts. Okay. Also, this first quartile is called as lower quartile, and the third quartile is known as upper quartile. Okay.
Ma'am, repeat it again.
The first quartile is your lower quartile. Okay, this thing. And your upper third quartile is called as upper quartile.
Ma'am, how it is 100%, like first is 1 to 25 and then 25 to 50 and then 50 to 75?
No, remaining 25.
It is up to 75% only, ma'am, no?
So till here it is considering like from 1 to 75. See, this is okay. This is your line. Okay. Now all the parts are containing 25%. So this is also 25. Suppose you have a rod and you are breaking into 4 equal parts. You can understand it like this.
Okay, by
So
this
if you add it
definition,
up
there should
to,
be fourth quartile also, from 75 to 100, right? That is where I can't understand. Like,
why it will be 4? Suppose you have a rod. Let's see. Okay, you have to break it into 2 parts. Then you need only 1.1 cut, right?
yes.
If you are breaking it into 3 parts, then you need only 2.2 cuts. Okay, then it
Yes.
will be 3 parts. Okay, so here we are dividing the whole data set into 4 parts. So 3 points are enough to break it into 4 equal parts, right?
Yes, ma'am.
Okay. Now next is 5-number summary. So 5-number summary is nothing but the minimum value first. Okay, then we take the 3 quartiles and then the maximum value. Okay, so minimum value of the data set, then the first quartile or lower quartile, then the second quartile, then the third quartile, and the maximum value. Okay,
Ma'am,
so
it
this
means
is
we can break it into 3 parts only, maximum.
no, it's not like that. I mean, here you see in the percentile, it was the 99 points that were dividing your data set into the 100 parts, 100 equal parts. And here the quartile gives you an idea about it divides the whole data set into 4 equal parts. It is these percentile, quartile are just giving you the understanding of how the data set is, how much percentage of or how much proportion of the value lie a particular lie below the particular point or above the particular point. It's clear.
Ma'am, I'm not able to understand it properly.
What's your doubt?
Ma'am, basically, we are dividing this line into three parts.
The parts are four, not three parts. The points are
Yeah.
3 points. Okay.
That is where I am also confused between four.
Ma'am, but
If there are
ma'am,
four parts, then
but after
75.
the quartile, you have shown that minimum and the maximum. In between that first
Yeah, this
quartile
is your
and the
minimum
median
value.
and
This
the
is
third
your
quartile.
maximum. Yeah, this
Then
is
only
your
three
minimum
parts are
value.
divided now. Yeah, ma'am, five numbers only. Yeah, this.
So suppose this is your minimum value in the data set. This is your
This
maximum
one.
value in the data set. And these are the different points. Q1, Q2, and Q3. Okay. So you can
Okay.
say that this is your first quartile, which means below this point, 25% data is there.
Okay.
Okay. And in this between first quartile and second quartile, 25% is 25% data is there.
Yeah.
Okay. And total, you can say that below second quartile, 50% data will be there.
Yeah.
Okay. And in between this Q2 and Q3, again 25% data will be there. Or you can say
Yeah.
below Q3, 75% data will be there in total.
75%.
Okay.
Yeah, ma'am.
Then this point, which is the maximum, okay, you can say that 100% data will lie
Yeah,
below
ma'am.
it. Okay.
Ma'am, this is
Most
clear,
of
but
the
if we will divide it into matlab four parts, four lines
Mhm.
in the between, then equally 20% will be there.
Ma'am, is that means कि after sorry 100 percentile is gonna be a maximum, so that's why the 75 percentile is third upper quartile.
Yeah, this is your upper quartile, right?
Yeah.
And this is your maximum value in the data set where the data set
Is it?
ends, you can say.
Yeah, it's 100 percentile. That's why it's the maximum number of.
Yes.
It means, ma'am, from 75 to 100, it is beyond 75 percentile.
Yeah.
That limit, that 75, the third will contain, right? Third quartile will contain.
Yeah,
That is
above
beyond
third
that.
quartile. Okay, above third quartile, the remaining 25% will be there. Okay.
Yeah,
And if
and
we
that is
see
maximum.
overall, yeah, that is max. Okay. So, and below the maximum point, 100% data will be there. Okay. Since you're dividing it into the four parts, that's why it is containing 25, 25. Okay. If you add 25 four times, then it will be 100 only, right? If you are dividing the data set into five parts, then the five parts will not be containing the 25%. It will be different than 100 divided by 5. Okay.
20%.
Okay. Then 20% will be there. Okay. Now it's clear.
Ma'am, if we
Yes,
divide
ma'am.
it in a five part, then what we say a third, like it's gonna be a
Then it will
five
not be
quartile.
quartile. Then you will be using some different terms. Okay. Then suppose you are
Okay.
dividing into five parts. Suppose it's your five part. Then
Yeah, ma'am.
okay. Then suppose this is 20, 20, 20.
Yeah, ma'am. This is only I'm asking.
Okay. Okay. So this will be your 20th percentile. This will be your 40th percentile. Okay. And it will be your 60th percentile.
60
It
and
will
then
be your
80.
80th percentile. It will be 100th percentile. Okay. Yeah, just simple.
Okay.
Okay. And each part will be containing 20% part of the entire. Okay. Now it's clear.
Okay, ma'am.
Okay. Now the next is the interquartile range. Okay. So interquartile range is third quartile minus first quartile. Okay. So basically it is giving you the middle 50% of the data. Okay. So suppose this is your Q1, and this is your Q3. So basically, this is the middle part of the data set. Okay. So the interquartile range is Q3 minus Q1. Formula is this. Okay. So it is the difference between third and first quartile. Okay. Clear? Any doubt till this point?
What is Q1?
No, ma'am.
What is Q1?
Q1 is the first quartile.
First quartile means, is it the mean of something? Mean of some values? Suppose we
It's not. First quartile is like it's containing below this point, 25% data will be there. It's not mean.
Yeah, 25%. Suppose there's 6, then it must be like 2, right?
Sorry?
If there are 6 observations, it must be 2. First two observations.
6 observations.
Suppose there are 6 observations. The first two observations come under. So the second observation is Q1, is it? Second data is Q1, is it?
I will have to find it by the formula. I cannot directly say.
Okay.
It will be 1.5, I guess.
You will have to find it by the formula. Okay.
Yes, the second observation will be.
You will have to use that formula.
Yes, ma'am.
Okay, then you can find it. Okay, so it's clear till now. So in week number 3, we studied about the how we summarize the numerical data. Okay. So first of all, we studied how we make frequency table. Okay. First of all, we see when we have less number of distinct values. Okay. Then we studied about when we have continuous data. We have a continuous variable, or we have a when we have so many distinct values. Okay. Then we make class intervals, right? My screen is visible or not?
No.
Now it's not visible.
Yeah, now visible.
Yes, ma'am.
Yes.
Okay. Okay, so we studied about the class interval, how we make frequency table, how we find frequency and their relative frequency. Okay. Then we see how we make histogram. Okay. We make classes on the x-axis and we take frequency on the y-axis. Okay. And then we make bars according to their frequencies. Right. So this was the histogram. Then we studied about the stem and leaf plot, in which we divide the numbers into 2 parts. Okay, which is the unit place is leaf part. Okay, and the rest is your stem part. Okay. Then we see about the measure of central tendencies, which are mean, median, and mode, and how we calculate it, and how they are affected if we add and multiply a constant to each data point. Okay, then we saw range, variance, and standard deviation, which is measure of dispersion, which is telling us about the spread of the data set. Okay, and also the effect of adding and multiplying a constant. Yes.
मैम आउटलाइनर में थोड़ा सा कंफ्यूजन था.
Outliers.
Ma'am, I have a doubt.
Yes.
Okay.
मैम आउटलाइनर में मतलब किसी ऑब्जर्वेशन से कैसे
See,
हम
there is
पता
a
कर सकते
formula
हैं?
for outliers here. Okay, I'm writing the formula here.
Excuse me, ma'am.
Yes.
Ma'am, I have a confusion in percentiles.
Okay. Okay, let's
Can
first
you
understand about.
like I was not available at that time, so I missed the starting lecture. So can you describe me a central trend, like what the difference between a central tendency and a dispersion?
So measure of central tendency tells you about the central part of the data. Okay, how the
Yes.
values are uh, distributed among around the central of the data set. Okay, just a second, I'm coming.
Okay.
Yeah. So measure of central tendency tells you about the central part of the data where the most of the typical values of the data set lies. Okay. And measure of dispersion tells you about how the data set or how the data points are spread out in the entire data set. Okay. Okay. So we were discussing about the outliers. Okay. So this is the formula which we can use. Okay. So this is your basically the lower limit. Okay. And this is your upper limit basically. Okay. So Q1 is your first quartile. Okay, minus 1.5 times IQR. IQR is what? Interquartile range.
Intern.
Okay, so any value or any data point which is below this point, okay, which is below
Yes, sir.
this value, that will be outlier. Okay, and next we calculate the upper limit, which is Q3. Q3 is upper quartile into 1.5 plus, sorry, Q3 plus 1.5 times IQR, interquartile range. Okay, so any value
Ma'am,
above this point will be your outlier. Yes.
may have taken some observations.
Sorry.
Take some examples, keeping the
Okay,
value.
example. Okay, see, we will have a doubt session on Tuesday. Okay, now you solve the questions which are given in activity practice assignment. Okay,
Yes.
you solve those questions. If you get any doubt, then we will solve those questions here. Okay.
Okay.
Ma'am, I have a doubt in ma'am grouped mean. Ma'am, can you please open this page of grouped mean example?
Yes.
Ma'am, I have a doubt that we are calculating mean by the midpoint in this continuous data or group data. Ma'am, if
Yes.
there is no, ma'am, if there in class interval of 30 to 40, there is frequency is 3. If all the data is above 35 or below 35, this will affect the mean, no, ma'am?
So that's why it's a point that from this formula we get an approximate mean. Okay.
Yeah, ma'am, this is not a accurate
Yeah, this is
mean.
not the exact mean that gives you an approximate mean of the data, because
Yes,
we are
ma'am.
assuming here that the values are lying around this point. Okay, we assume this point, assume this thing. That's why we
Okay,
have
ma'am.
taken the midpoint of the interval.
Okay, ma'am. Thank you.
Okay. Yeah. Any other doubt?
No, ma'am.
Now it's clear.
Yes, ma'am.
Yeah. So the day after tomorrow, we will be having the doubt session on the same week 3. Okay. Now you can solve the questions for practice assignment and activity and the grade it. And if you have any doubt, then you can ask it there. Okay.
Ma'am, percentiles.
Okay. Percent. Yeah. What's the doubt?
Ma'am, percentiles top whole topic.
Whole topic. We did not understand different. Okay. Which divides your
Percentile.
whole data, which divides your whole data set into 100 equal parts. Okay.
Yes.
So this is your suppose data set. So these are different points, 99 points that divides the whole data set into 100 equal parts. Okay, it's clear. Okay. So suppose this is your 30th percentile. Okay, so you can say that below the 30th percentile, 30% data will be there, and above the 30th percentile, 70% data will be there. Okay, and how we compute it? So first of all, if you are given a data set, you find the number of observations there, which is your n. Okay, then you arrange the data set into increasing order. Okay, then you find out the value of NP. So suppose if you want to find 40th percentile, then the value of P will be 0.4. Okay, if you want to find 70th percentile, then the value of P will be 0.7. Okay, how we find it? Like 70 divided by 100. Okay, okay, and the value of N. So we find the value of NP. Okay, and then you see that whether it is an integer and not integer. If it is an integer, okay, then the data point at that position, if it is not integer, let's say in this example, if the value of NP is integer, then what we do? We take that integer plus next integer. Suppose the value of NP is 1 here, okay? So the first observation plus second observation divided by 2. So basically it is the average of NP, okay? This NP term and NP plus 1 term. So we take average of it, and if NP is not integer, okay, suppose it is 4.5, then we take the smallest integer greater than NP. Okay, so if it is 4.5, then the smallest integer greater than 4.5 will be 5 only, right? Then the fifth observation will be your 100th percentile. Now it's clear?
Yes, ma'am.
Okay. Yeah, any other doubt?
This percentile is same as the one get marks in the J mains or other exams like that.
Yeah, it's same.
Suppose one gets 99%, what does it mean?
What it means that the rest, suppose someone having 99 percentile, okay? So basically telling you that 99% of the student has scored less marks than you. You are above that 99% of the students.
Okay, and when someone gets 100 percentile,
Then you will be having first rank, I think.
so only one. Suppose too many students gets 100
Yeah, so
100%.
which means that like suppose you have exam of 150 marks, okay? And suppose 10 students got 150 marks,
Yes.
which means the last data point is having 150. So it will be 100 percentile like this. Okay, any other doubt?
Ma'am, like what about like 100 percentile? So that particular term, like and a term, like also like part of that whole like that data set. So like how can we say ki you are above 100%?
So, see, no one is there who has got more marks than you in that case. That's why it's 100 percentile. It can be equal, but not more than that.
Percentile represent only the position where you are in that data set.
Yes.
Hello,
Yes.
ma'am.
Yeah, hello.
Ma'am, in the week 3 content in lecture 5, there was a topic in like percentile, computing percentile. So in the activity questions and also graded assignment, there were multiple questions on the topic percentile. So I was facing difficulty in finding percentile. Suppose a data set is given of marks of students, and we have to find 25th percentile. So the Usha ma'am has told in the lecture that there are two ways to find that percentile. One formula is NP and other is the Google Sheet algorithm. So can you please tell me more on this? I was facing difficulty by solving from that algorithms.
In Google Sheets.
Yes, in Google Sheet.
Okay, so see, Google Sheets will not be asked in your exams. So that's why we are focusing on this manual things only. Okay.
This NP formula.
Yeah, this is the formula to find percentile. I mean, this is the procedure that I have told you. Like if it is an integer value or if it is not an integer value.
Can you please repeat this? I was not in the meeting. I recently joined this.
I have already repeated it 2 times. Okay, so see, you have to find the value of NP. Okay? And you have to check whether it is an integer or not.
Okay.
Suppose if it is an integer, suppose it is 4. If it is not integer, suppose it is 5.5 or 5.6 or anything you can take.
If it is 4, then we will take the value of fourth observation, and if it is 4.5, then we will move to fifth observation, right?
If it is fourth and value of NP is 4, then we will take the average of 4 and 5 observation.
Okay.
Okay. This is a position, not the values. Okay. Fourth and fifth observation, average of fourth and fifth observation. If it is integer.
Okay.
In this case. Okay. And if it is not integer, then we take the smallest integer, which is just greater than this. So it will be 6 in this case. Okay. So we will be taking the value at this 6th position.
So in this case, we will not take the average. We will take 6.
Yeah, we will not take the average.
Okay. Thank you, ma'am.
But the ma'am, as you said in the example, NP is equal to 10, and the last in the percentile topic, NP is equal to 10, but the NP plus 1. Yeah.
Sorry?
Here in the example, the NP is 10. Then the average of the 10th and the 11th, but the 11th data is not present here.
Yeah, since 11 is not present here, the 10th observation will be the 100th percentile. Okay, I have told this thing earlier also. So what 100 percentile tells you that 100% data should be below it. Okay, so definitely the last value will be 100 percentile. Okay, which is 79 here.
That means the formula is not valid here. Can
By formula, if you say, then it will be different, but by definition, you can say.
Okay.
Right.
Ma'am, if in variance, suppose I calculated the variance is 25.6 something like that. So what does it mean?
So see, there is a variance, okay, which gives you the squared units and the as in the data set, and there is a standard deviation, okay, which gives you the same unit as in the data set. Okay. So suppose this is your mean and this is your standard deviation. So generally it gives you an idea that most of the values will be lying in this interval. Okay. Like suppose x bar is your 60 and sigma is your 10. Okay. Then you can say that most of the values will be lying in this part, like 50 to 70 in this way. This is the standard deviation, not variance. Okay.
Then
So
what
basically it gives you the spread, how the data points are spread out around the mean value. Okay.
this can be
How
calculated
they
by
are.
a standard deviation only.
So standard deviation and variance is not I mean, they are related to each other, you can say. Standard deviation is nothing but the square root of variance. Okay.
Okay. Then why do we need to variance? Just to calculate the standard deviation, I know, but why do we
Because variance is not, see, variance is nothing but the variance is giving you the units, the data value in the squared units. Okay. So that you can directly use. So we use standard deviation.
Okay.
Ma'am, help.
Yes.
Ma'am, the formula which we assigned before for the outliner, it's give the range of the outliners for the observation.
Sorry. This formula, last formula.
Outliner, yes, ma'am. It's give the
Outlier.
range of the given data.
See, it tells you that any value which is below this point, okay, that will be considered as outlier.
Outlier.
Okay, and if
above
any
this point.
value below, sorry, above this point, okay, so that will be also outlier.
Yes, ma'am. Thank
Okay,
you. Okay.
now it's clear.
Yes, ma'am. Clear.
Ma'am, suppose there are only 4 data available, and if I want to calculate the quartile, then the one data will lie in the first quartile, that is Q1, and the next 2 data will be lie in the Q1 and Q2. I'm not able to convey the message, but have you got the essence of my message?
So you have only 4 data points.
Yes.
So we will find out the values and then you can conclude. Okay, I will not say directly without calculating these parts. And also this is a very small data set. Okay, then suppose it's 10% values below the first percentile, then definitely it will be one value only. Okay, so your quartile will be
Then we
like,
have to calculate according to the percentile method. No?
sorry.
Then how can we calculate which data is falling the Q1 range, that is minimum to Q1?
See, so first of all, you will be having some values, 4 values. Okay, now you calculate Q1, Q2, and Q3. Okay, so Q2 will be in middle of this point, like somewhere here. Okay, average of these two. Okay, Q1 will be, I think, somewhere here. Since I have not calculated the value, so I am assuming that it will be here. So 10% will be containing, I think, only one value.
Okay.
Actually, you will have to see it because it's a very small data set. Okay, I will not say anything directly without calculating it. First, you will need to find out the values. Okay, you will be having some data points. Calculate these values and then see. Okay.
Okay.
How does it work? Okay. But the definition is the same. Like Q1 will be having 50% of the data below it. Sorry, 25% data. Q1. Okay. Now may I end the session?
Yes, ma'am.
Yes, ma'am.
Okay. Okay. Thank you all.
Thank you.